You know, it sounds like something straight out of science fiction, but we might actually be trapping ourselves on Earth. This isn't a movie plot, it's a very real, very terrifying possibility called the Kessler Syndrome. It's a scenario where just one crash in space could set off a chain reaction that wipes out every satellite we have, essentially rewinding modern civilization in an instant. To really get it, we need to understand what's truly at stake.
So, to really grasp the scale of this, let's start at the end. Let's just imagine for a second a world where our connection to the sky is just gone, severed in a moment.
I mean, what would that actually look like? What if everything we totally depend on, everything that makes our world modern, just switched off?
Well, it wouldn't be a slow decline. It would be an immediate, full-on collapse. Global communication? Gone. GPS, which is kind of the silent engine of our entire world, would just fail. That cripples everything from air travel and shipping to the traffic lights in your city. Financial markets? They'd freeze solid, because they actually rely on the hyper-accurate timing from GPS satellites to process transactions. We'd be completely blind to incoming hurricanes, and emergency services would be a mess, struggling to coordinate. Our entire global system is built on this invisible foundation of satellites we suddenly can't reach.
Okay, so what in the world could cause a catastrophe that totaled? Let's meet the culprit behind this whole nightmare scenario. A runaway chain reaction happening right over our heads.
Way back in 1978, a NASA scientist named Donald J. Kessler basically saw the future. He put out this warning. He theorized that if low Earth orbit, that's the space right above us, gets too crowded, one little collision isn't just going to be one collision. Oh no. It would be the first domino in an unstoppable cascade of pure destruction.
And this breaks it down perfectly. See, it all starts with just one initial collision. That impact smashes those two objects into thousands of new pieces of debris. Now here's the scary part. Each one of those fragments is basically a bullet, screaming around the Earth at incredible speeds, which hugely increases the odds of them hitting something else. And when they do, those new collisions create even more debris, and the whole process just repeats and grows exponentially until the entire orbit becomes a lethal, deadly minefield for centuries.
Now this is what's absolutely wild. The physics of it all. We're not talking about gentle little bumps up there. At orbital speeds, we're talking over 17,500 miles per hour. At that velocity, a tiny, marble-sized piece of space junk hits with the exact same explosive energy as a hand grenade. That's why these collisions aren't just fender benders, they are utterly catastrophic.
And the main danger zone, the real red zone, is right above our heads. Low Earth orbit, or LEO. This is where we have the International Space Station, our weather satellites, and all those new mega constellations for internet. It is incredibly congested up there, which makes it the absolute prime location for a Kessler event to kick off. Now, higher orbits are way less crowded, but there's a catch. Any junk created that high up is pretty much permanent. It's not coming down.
So for decades, this was just a really scary theory. But then, we got proof. Let's move on to the real-world events that prove Donald Kessler's warning was terrifyingly accurate.
The first major smoking gun came in 2007. A Chinese anti-satellite test intentionally blew up one of their own weather satellites. That single event created the largest cloud of debris in history. And then just 2 years later, it happened for real. An active Iridium communication satellite accidentally smashed into a dead Russian Cosmos satellite. This was it, the first time two intact satellites had ever collided, proving that Kessler's theory was absolutely no longer theoretical.
And the scale of this is it's mind-boggling. That one test in 2007 is estimated to have created over 150,000 fragments, larger than a centimeter. 150,000 new, untrackable bullets just circling the planet.
So, with the danger now completely undeniable, the question shifts, right? It's not if anymore, it's how. How in the world do we respond to a threat of this magnitude? Let's take a look at the options. Okay, so scientists and engineers are coming up with some pretty incredible ideas for what they call active debris removal. We're talking about stuff like chaser satellites that would literally hunt down junk with nets or harpoons, or robotic arms that could grab old satellites. There are even ideas about using ground-based lasers to gently nudge debris out of orbit. But all of these face huge challenges. They're unbelievably expensive, they're super complex, and they all carry the risk of actually creating more debris if anything goes wrong.
And that right there brings us to the core political problem. You see, space is a classic tragedy of the commons. It's this amazing shared resource that everyone uses.
But the debris created by one country or one company threatens everybody. And yet, there's no global agreement on who should foot the bill to clean it all up. It's a collective problem with no easy collective solution.
So all of this leaves humanity at a really critical fork in the road. And honestly, the choices we make in the next few years are going to decide our entire future relationship with the cosmos.
When you boil it down, there are really only two ways this can go. In one future, we just fail to act. Low Earth orbit becomes this impassable barrier of junk, and we effectively trap ourselves on this planet. Our dreams of space exploration just halted for centuries by our own garbage. But in the other future, we cooperate. We develop the technology and the policies to create a sustainable future in space, keeping our highway to the stars wide open for all the generations to come.
So really, the final question is for all of us. The orbital environment is fragile, and that tipping point is so much closer than we think. What are we going to choose? The time to actually do something about this is now, before the very path to the heavens becomes completely impassable.